The following content is dark mode friendly. Hello friends, it's me, Warasa here, welcome back. Now this isn't the normal type of content I'd make, but I was wondering what to make for this month, so here we are. This equation is probably the first one you will learn, other than E equals mc squared. F equals ma is described by Newton's second law of motion. Now for those who don't know what F equals ma means, here's a small breakdown. F is force, or in today's example, weight. Is mass, and A is acceleration, which can be exchanged for the gravity that said mass is influenced by. Here's the practice question. An object exerting 10 kilograms due to Earth's gravity, acceleration equals 9.8 meters per second squared, has a volume of 10 liters. What is its density? Well, F equals ma, so 10 kilograms equals times 9.8, or 9.8 m. If we move it around a bit, then we get equals 10 divided by 9.8. The answer to the equation would approximately be 1.02 kilograms. The equation for density is D equals M over V. This is just a side note, but in the video I say D equals M over V. Density in the actual equation isn't represented by D, but by a Greek letter, of which I forgot how to pronounce. But here's a picture. Continue with the video. The mass of the object is 1.02 and the volume is 10 liters. So the equation must now become density equals 1.02 divided by 10, which makes density 0.102 kilograms per liter. Now that might sound good and all, so let's do the same with water. This 10-liter bottle of water exerts 10 kilograms. For the sake of simplicity, let's ignore the water bottle. Now let's try moving the equation around before doing it. Let's turn F equals ma and density equals m over v into density equals F over a over v. Yes, very beautiful, you're welcome. Anyways, if we plug everything in, then you would get density equals 10 kilograms divided by 9.8 meters per second squared divided by 10 liters. Because all of the variables hold the same value as the previous question, you would get the same answer with a density of 0.102 kilograms per liter. Now you're gonna ask, wait, isn't water's density at room temperature at sea level 1 kilogram per liter? The answer to the equation says no, but the textbook says yes. So what's wrong? Either the standard for which modern chemistry measurements are based on are false, or our equations are. Yeah, it seems impossible that such an old, useful, and popular equation is wrong. I'm talking about F equals ma, by the way. The truth is, neither the equation nor the textbook is wrong. We are wrong. Let's take another look at F equals ma. Our input was 10 kilograms for both questions, and acceleration was also 9.8 meters per second squared for both. First problem is the unit. Force is measured in newtons. Our input was in kilograms. 1 kilogram is equivalent to 9.8 newtons, or 10 newtons in some textbooks, which is wrong. I hate it when they do that. Let's plug our newly discovered stuff into the equation. 9.8 times 10 equals 9.8 m. 98 equals 9.8 m. M equals 10 kilograms. That makes sense. Another approach would be changing the unit that gravity is measured in. 9.8 meters per second squared, it's in seconds squared, to dictate that any influenced object would increase by 9.8 meters per second in speed per second that passes, or 9.8 meters per second, is equivalent to 1 g of gravity. So that means if an object exerting 10 kilograms of force under 1 g of gravity, then it would have 10 kilograms of mass. Since the ratio between 9.8 meters per second squared divided by 1 g and 9.8 newtons divided by 1 kilogram is equal, then the conversions are mathematically correct. This video is basically a really long tutorial telling you to check your units. I thought of this little conundrum and decided to make it a video. If you like today's content, make sure to subscribe and leave a like. I will make another one like this if it gets 10 likes. Thanks for watching, and remember that no matter how much you know, there's always something to learn. Have a nice day.